Okay. Hello, everyone. Thank you very much for coming to this workshop. We're quite pleased to see how many people were interested. Yeah, so we have this agenda. We'll try to follow.
This is asking.
Yeah,
I'm Ishan, and that's Ryan. We'll be taking part of the 6 sessions we have. And so I sent this link in the email that you've all received. This is our workshops repository. So it has everything that we are going to talk about, all the links, all text. And so it's not really necessary for you to take notes unless you feel something is very important, because especially for the content that you're already seeing, this is all accessible to you. And we're also recording this workshop, so later we'll upload it on Carl Sagan Institute's YouTube channel, so you can just go back and revisit some parts of it. Okay, so I'll let Boston just start with this.
One of the things, this is sort of like an open workshop that we have discussion back and forth. So if you have any like immediate questions, it's fine. Just bring it up with us over our name.
Yeah, I had to do it.
Because like the topics we're going to cover are pretty broad, and a lot of applications of GitHub will be discussed. So it's kind of will feel like trying to pick some of variables, but don't be overwhelmed. And again, as I said, focus on just taking it in and identifying things that you like, and you can follow them up later, and always go back to the repository.
Okay, so we'll start with a bit of theory before we get hands-on. So when we were thinking of doing this workshop, thinking of the motivation of doing this, we found this paper from Diana Mani in Nature in 2010, speaking of these really huge codes that people transfer to each other, sometimes for decades. She calls this monster code. I am sure some of you have experienced this during your career. I have had that for my master's internship. It wasn't traumatizing, but close. Yeah. And so the thing is, so this entire paper, Why Scientific Programming Does Not Compute, is about how scientists are quite bad at programming usually. And so this paper comes with a survey. It's already 10 years old almost now, but I think it's still pretty relevant. And so she shows that almost 40% of scientists spend at least 1/5 of their time programming. I think now it is even higher than that. And the thing that is pretty interesting is that only half of scientists think they have a pretty good understanding of software testing, and only 1/3 of them at that time thought that it was actually important to have a pretty good formation in developing software, which of course is really important, but we'll show that. So in the end, she gives 5 tips to make your scientific code more robust. First one would be to track your material, know what material you're using, know your sources, things like that. Write testable software. There is a way to develop code that actually favors that, and then actually test your software. Encourage sharing of software as well, because the more people will be looking at your code, the more suggestions you will have about this. And the final point is to use a version control system, or VCS, and that's what we are here for. Speaking so of Git and GitHub, that's what's in. So for now, I've been only talking about programming, but VCS and so Git and GitHub are not only for that. One good motivation is also this kind of slide. You can use Git and GitHub for basically anything. So even Word documents, or even if you prefer LaTeX as well. The thing is to avoid having all these kinds of different versions of one file or one project, but still keep everything organized and still get track of everything you did. So a summary of this workshop. We'll so briefly during this first and second parts show the theory, what is VCS and why we want to use it. Then we will create your GitHub account and create and understand your first GitHub repository. Then we will head over to Ryan, who will show you an actual test case with Git. And we will go through best practices for code accessibility and documentation. Then Ishan will show us how to get from a simple Python script to a full publishable package. And finally, we'll finish by showing you how you can use GitHub to create your own website. Again, if you haven't seen it, I'm putting here back the link where you can find all material. And before we start, I want to give a bit some kind of disclaimer about the difference between Git and GitHub. So Git is the actual version control system. It is basically the tool that allows you to do what we will do during this workshop. And GitHub is the hosting service that comes with it. So yeah, just see Git as the tool and GitHub as the service around it. Okay, so the non-VCS way to do things would be to start with developing one code and by someone for a given purpose. And then you would have many other people who would get their hands on this code with or without consent from the first developer sometimes. So people just implementing new things to the same version of the code, people copying it and developing their own version after that, people copying it and never really finishing anything, and some other folks that will try to merge different codes together. And the thing is, so this is how you get this kind of monster codes that the Amaral is speaking about, where you don't know in the end who did what and when was that and what for they developed certain parts of the code. And so VCS is basically the way to keep all of this mess organized and keep track of everything you did. So a way to represent this would actually be this graph. You will in the end have one major version of your code, people still working on it on a parallel way, but you will keep track of every time someone copies your code, of every time someone implements new features in your code and things like that. So this is basically VCS. Now we will go to Git and GitHub more specifically. And it is, as you can see, pretty simple to understand. The thing that is a bit difficult usually that people think is understanding the terminology. There are lots of different terms. So I will go through the basic ones during this presentation, but you can find on the repository we created a link to the GitHub glossary, where you can find basically all the terms that you will need today. Okay, so the code, your actual code, when you create it on Git and GitHub, is called the repository. You can also see it as a GitHub project. Basically, it is simply the folder that will contain all your project files and everything you do on your code. And so the main version of your code, the one that is supposed to be bugless, if possible, the one that should be available to everyone to download if you want so, is called the master or the primary. And so all the people who are working on your project, on your repository, are called collaborators. So you can simply, from your GitHub account, invite them to work on your repository. And the way they work on your code are actually called branches. So these are these parallel development versions of your code. So they are created, modified, and then in the end merge with the final version of your repository. And so now we will see basically all the terminology of creating a branch and everything you can do through this. So this is called the GitHub flow. The horizontal blue line you have on top is the master or primary, and the one below it is the actual branch. The first thing to do is actually create a branch, of course. So basically, this means that you will copy the files from the repository, from the master, in an environment where you can do whatever you want without affecting the master, of course. So if you have a new idea or anything like that, you can experiment, you can modify whatever file you want. If in the end it doesn't work, it's no problem, you can just abandon the branch. But this is really the way to be secure that you will not mess up the primary. The actual stuff you do on your branch, like adding files, editing existing files, or even deleting ones, this is kept in the history of the code through what we call commits. So really, this creates like a transparent history of all the modifications you will do to the files, because each commit has an associated message where you're supposed to say what you have done and possibly why you have done it. So once you're happy with all the modifications you have done, you do what we call opening a pull request. So basically, this means showing to other collaborators that your modifications are ready to be reviewed. So this is a way to initiate discussion. So you can do this, of course, when you are ready to add your work to the main project, to the primary, but also just if you want to share some ideas or if you are stuck somewhere and you need help from your collaborators. So once the pull request has been opened, all collaborators of your code can see what you did. They can discuss it, review, check if everything is fine according to them. And if it is indeed the case, you will be able to deploy your code. So this is the final security step before actually merging. This is done for a final testing, just to make sure that you will not, again, mess up everything by adding what you have implemented. And finally, you can merge your branch into the master. And this is how also every modification is tracked. The record of every merging, of every branch merging is preserved in the GitHub flow. All right. So this is a specific branch. So people working on the same repository. Of course, you can still do the old way of copying the repository. This is called cloning. Basically, through that, you will copy the files on your computer. You don't need to have a GitHub account to do that. You can, of course, use it offline, anything like that. But the way that if you work with GitHub only, GitHub recommends would be actually to fork a repository. So this basically means copying the repository to your GitHub account. So it will be an exact same copy, except that this new repository will be owned by you. And it is still attached to the original. So you can still, so if you do modifications on your forked repository, you can still submit these modifications to the original work. You can by requesting pull requests, and you can still, of course, import updates that have been done on the original work to your repository, to your copied repository. So yeah. So I've been essentially talking about doing things with other collaborators. Of course, GitHub is still interesting if you work on your own on the one code. Of course, because you still keep track of everything you do with this method. You don't have to create an actual log or things like that. And again, using the branches is really a good way to make sure you will not mess anything up just by implementing new ideas that you're not sure will be working now or not. Okay, so now that we have this, we'll start setting up with a new account. So I'm sure you have already one, but in case not, I invite you to go to github.com/join and just choose the username, give your email address and the password. So people here know GitHub account yet, or
how many of you don't have
Okay, yeah, so we can give you 5 minutes to do this. If you need help, don't hesitate.
Yeah, that's right.
Sorry.
No, I think this is for tomorrow. The sign up is for otherwise,
Yeah. Okay. So I know it's recently which does
Yeah.
Does anybody need more time?
So once you have created your account, you will end up on this web page. So not with this beautiful picture, of course. This is called your dashboard. It is really the main hub of all your activities on GitHub. So this is a public page. People will be able to see your profile info that are here on the left with picture and everything. You can give your website too. People will be able to see your repositories on the tab that you can see on top, unless you have made them private, but we will see that later. And most importantly, people will be able to see how you contributed to your repositories. So basically, your activity since your account was created and here displayed in the last year. So this grid of green dots is how GitHub takes track of your activity on your account. The green, the more changes and the more commits you add to your repositories, the greener the dots will become. And another way to see this is this graph over there. It's a bit difficult to read maybe, but basically it tells you in what kind of activity people are specialized. So this profile here is mostly commits, 51%. They do a lot of pull requests too, but you will sometimes see profiles of people who only do code review or bug issues. Okay, so now we will create the first repository. To do that, you will see in the upper right corner plus symbol. Just click on it and click on the new repository. You will be invited to choose a name for the repository. So try choosing something short and memorable, as they say. For now, you can just name it new -repo or something like that. Also add the description to your repository. This is optional, but we highly recommend it so that people can actually have a brief overview of what you'll do. You can then choose the status of your repository, if it is public so that anyone can see it, or if it is private, and in that case, you only can see it and the collaborators that you will invite to work on the repository. And finally, the last option is to initialize your repository with README. So again, this is optional, but we highly recommend it. It is the how can I say? It is really the first thing people will see when they go on your repository. That's where you should put all the important info and mostly the material you want people to Okay, so let's do that. I think a couple of minutes should be fine. Again, if you need some help, just create a.
Yeah, no, I was going to say that you can skip the git ignore and license for now. I will cover it later when I talk about Python, creating a package. But just so you know, git ignore is a file that contains a list of file types that Git should not track. So if you have a code, every time you run a code, it creates a lot of auxiliary files or cache files that are basically, yeah, they're created in every run. They're not needed to be tracked. And so it has a list of files for every language. And so we'll select one for Python later. And license is just to let people know how much you want to share your code. The default is a MIT license, which is basically anyone can use your code for whatever they want. And that is the open source method of doing. Yeah, but you can leave it. Here's a solution. Yeah. Please feel free to ask any questions at any point. Yes. No. Oh, this is Markdown. So, are you going to talk about Markdown or? I won't talk about it. Okay, so I can take a quick pause and maybe introduce. So, the default language that GitHub uses for its README and any other text documents is Markdown. So Markdown is a markup language like HTML or any other, well, there's restructured text, but it's basically a simple language that can that you can use to format your text. So for example, if we go here quickly, I have put a basic Markdown guide. So let us see this. So Markdown is basically, it's very simple. So for example, you have a header. So if you do, okay, I think I have a better one where it actually shows. Let's do this. Okay, so basically, like, this is a heading, and these are some list items. It has simple schemes for everything like that. If you want to include a link, you can just say Google, and you can go to Google and lovely create a link to Google. And so this is like a very simple way of formatting your text. So you can also go one step beyond. You can create code. Like if you want to include a code in the middle of your text, you can use something like basically these, I don't know what these symbols are called, but for example, this is something that we'll be using. So it will create a code block. So that is a standard, probably the most simplest markup language, and that is what GitHub uses. So the extension is .md, and that is what your README file is, readme.md. And if you open to edit it, you will probably see that it has 2 hash marks. And so that is a heading. That's for heading. So yeah. Oh, just move this thing up. Yeah. Thanks.
Okay. Anyone still hasn't created a new repository, or are we good? Okay. So. Okay. Okay. Now it works. So when you have created your repository, this is what it will look like. On top, you will have your username / the name of your repository. You have on the right the number of people who have seen it, watch, the number of people who have downloaded it, that put that as a favorite, and the number of people who have forked it. You will have a lot of different tabs that I will not go through all of them, but basically you will spend a lot of time on the code one. You have settings where you can manage everything as the status, like private or public, if you want to change it and things like this. Just below, you have the description of your report that you just chose. And you have this bar where you see the number of commits. So for now, we only have one, which is just creating all files and the repository. The number of branches, one for now, the master branch. And in the end, the number of contributors. So for now, it's only. Just below that, you can choose what branch you're working on. So for now, we will have master, so that's good. You can click on the button to create a pull request right now if you want. You can modify files using these buttons here, and this is for anyone to clone or download your repository. So again, not needing a GitHub account like working. Below that, you will have the latest history of your code, so the last commit, which for now is the initial one, and what it contains. So the initial commit was simply to create the readme.md file. And below that, you will always have that on the first view of your repository, which is the content of the readme.md file. So initially, it is created with your new repo name as header, and just below that, a text with the description of the repo. But of course, you can change that as Ishan just showed. New repo is simply a header, and below that is simply a simple text. Okay, so now that we all have our first repository, there are different ways to manage all of them. There are different ways to create repositories, to fork them, and things like that. The one we just saw is simply to do everything through your browser. It can be useful because basically this is available everywhere where you have an internet connection. You don't have any compatibility issues with your operating system and things like that. So you can create and fork repositories. You can manage all your files and edit them directly on GitHub websites. This is the place where you will see all the other GitHub accounts where you can discover new repositories that you might be interested in and things like that. But the main habit would be that it's impossible to run your code online. GitHub doesn't provide for compilation of codes and things like that because it just simply cannot provide the processing units for that. So the second option will be to use a graphical user interface or GUI. So there are multiple software options available for this. They're called clients. You can find them on the website that's put on the repository. So this is really good because it combines the Git functions, so everything we've been talking about just earlier, like commits and pull requests. So it combines that with all your favorite text editor functions, completion and indenting and things like this. It is usually considered as the most user-friendly way to manage your repository. And it is really nice because most of these GUI clients will have a graphic representation of the collaboration on your code. So I just put a small example down here where you can see all the different collaborators as colors and when and what they modified in a simple way, because sometimes when a lot of people are working on the code, even if it's DCS, it can be a bit difficult to understand. Okay. And so the last option is the command line interface. So those of you working on Linux and Mac will be used to this. It is really nice because usually people like that because you have control over everything you do. You can also, just like a bash script, create your custom script that you can automate. Like for instance, if you want to do a commit of your repository every day at a specific time with a pre-generated commit message, for instance. And one really nice advantage of the command line interface is also that if you're stuck and need help. If you look online for help, you will most certainly find documentation about this method, about the command line. So, okay, so this is now done for theory. Now we will get hands-on with Ryan. We will use the command line interface now so that everyone has the same thing. And I invite you to go to this website, depending on your operating system, Linux, Mac, or Windows. Don't hesitate to ask for help if you need anything. I am Linux and Windows user. I think you're Windows, yeah. Yeah, okay, and Mac too, okay. So yeah, don't hesitate.
Linux and Mac will show anything happen or just go to your command line and type get hyphens and if something shows up, you have to install it. And in Mac, if
they have it,
if
you
it
can
does, if they don't
control time.
it will automatically give a prompt to install it. So it's very simple. For Windows people, you have to go to that link. So this is a Windows get bash. This is does anyone have Windows here? Anyone using okay. So this is what you want.
Oh yeah, of course. Yeah. Oh, everything. What is this presentation software?
Sorry.
What is this presentation software?
Fox PDF. It's not, well, it's not free. It's almost free. This is free. It gives you more features for free.
Okay.
So yeah. I'm going to go through the process of setting up.
Ryan, do you know what to update it on? Update it? Yeah.
Can't you just use like APK here? Like, really you are very but yeah, I usually go to that.
Yeah, really. Yeah. I'll just stay through and all.
So I think everyone's
Anybody else have any, not have any students?
okay. Okay, that didn't help. Let me increase it. Is this good? Okay, great. You really get 12 minutes of it.
Yeah, I'm gonna go back. Yep, I'll start. All right, so I think we're all set to get started with this. All right. So the very first thing that you should do now that you have your prompt open that you have Git with is to configure your name and your email address with your Git, I guess, account. So these are the two commands that you should do. Just first off, you'll only have to do this once, just right now that you've installed it. So git config -- global user.name, and then just put in your put in like an actual readable name, and then the email address that you associated with your GitHub. There is a way to check this. Yeah, you could just, if you just do it again, it's fine. Oh. So I think one of the ways you can check it is git config list.
It should come under user.name. Oh, enter.
There it is. Okay.
So git config --list, it will list all the configuration variables that has been set up, and towards the end you'll find user, user.name and user.name.
So right now the
yeah. So it has been set up for me.
Maybe let's use
What the
Q maybe.
Yep, of course. There you go.
Git
No, put your real name in there, and then put. You can put either one. The reason you have this is that you can then have an associated username and an email with every change that you make to your repository. So just whatever name you want to be associated with those changes. All right, does anybody still need more time? Everybody set? All right, so, all right, now we're going to. Yeah. Oops. Do we need more time?
Yeah, actually. I want everything in the.
So everyone okay?
Yeah.
Yeah.
Any further? Okay, so we need more time. Okay.
And so yeah, and again, so this is so this
Cool. All right, so moving on. Yeah. All right, so now we're going to do this action called cloning. Ash we talked about before. All this is doing is essentially downloading your repository from the GitHub internet land to your computer, so you can actually edit the things that are inside of it. So just so you know, going forward, we have these like two different regions. We have GitHub World, which is up here. It's all just online, it's a collaborative thing. So we have down here, this is stuff that's happening on your computer. So, go ahead and do this command in your bash prompt. So it's git clone and then the full URL for what the repository is that you made with Bastion. That includes both the username and your project name, and make sure it ends with that.
You can actually maybe go to the browser and show that.
Yeah.
You can get the link by just clicking.
yeah, you can just copy the link from the browser. Just make sure you add git at the end.
So for example,
Do you have that new repo?
So for any repository, if you just go to this button here and push it down, it gives you a link to copy it, like in case you want to clone it. So this is your URL for the repository, and so you can just copy and paste it in your terminal.
Do you have like a new repo thing? Should I make one?
Yeah, sure. Go ahead.
So I can do this along with people?
Yeah, that'll be good. Nice. We're just going to do it along. Okay.
That's what it recommended me to do, so I'm contractually obligated to do it. I'm not trying to close it, I'm trying to
Just maximize it. Oh, okay.
I'm trying to minimize it.
Okay.
Yeah, there we go.
So you can just get copy that. Yeah.
press that button and then paste that in there.
I will say cloning is and it clones everything.
Just does a bunch of things. Okay, so
Everyone, okay with this?
everybody see what happens. Here's the information again. Yes. Yes, input your GitHub username. Yeah, sometimes it's weird. Sometimes it doesn't store it. It's bizarre. I'm not sure what happens, but
I'm not sure. I didn't want to.
Yeah, to me it didn't.
Dollar is just a prompt.
yeah, you see how there's the $sign right here on my prompt?
That is just
Okay.
a,
Yeah.
that's an indicator that it's a new. People are
All right, so everybody, you should be able to now move into the directory. So this is, if you haven't used Bash before, the way that you move between directories is this C command right here. So you should cd into whatever the name of your repository is. So importantly, it took your repository and put it into a folder called the name of your repository. That's what this clone command did. So move into that repository, and then you can do, again in Bash, this ls command. Yeah, right here.
So we move into the directory, then you do ls -a is basically listing all the files in that.
Yep.
Files and folders.
Yeah, CD means change directory and essentially list, sort of like list, I guess. Yeah. All right, has everybody been able to see this?
You see.
Oh, there's a question over here. Yeah. All right, so while people are finishing up that last step, I also want to bring up this other idea where, just for the sense of completeness, there's two ways that you can actually get your repository onto your computer, both through cloning, but also through this idea of initializing. So say that you have a content code on your computer already. What you do is you use this command called git init right here. So what this will do is, if you're in some directory that has a bunch of code that you already have written, you do this command and it'll set up a repository on your computer that contains essentially everything in that directory. So this is sort of, instead of saving things from starting things in GitHub and moving it to your computer, you can start things on your computer and then do this thing called git remote add origin, which we'll get into some of the specifics of this in a little bit. But the idea being that you're going to create a link to a repository that you then have online. So this is the way that you start locally and move to the internet, and the way that we talked about before with cloning is how you move from the internet locally. So we don't have to do this right here. This is just for completeness. In case you have a bunch of code that you want to get.
So there are three steps. You have a local set of files. You create a Git repository for it using git init. So now you have a local version control system, and using git remote add origin, whatever the link is, you're linking that local version control system or local Git repository to a cloud, which is GitHub over there, and you have an account on GitHub.
And I guess we might as well introduce it now. This word origin here just means it's the name of your remote repository. So it's just a shorthand. You don't have to write out this whole URL every single time. It's just a shorthand to say we want to push to this repository. All right, everybody has been able to clone their new repository onto their computer. Any problems there? Okay, cool. So let's move on to the idea of the Git workflow. So this is the main things that you're going to be doing with Git on your computer, which is the idea of essentially committing. This is this word here, commit. All it's doing is it's sort of saving a state of your code. So just like you would normally on your Word document or something like this, you press the save button and it would save the current state of it. What this is doing is it's saving different states over time, and then you can always go back to a previous time in which you did this commit action. All right, so here is the, so we're now gonna go through this quick Git commit process. Okay, so first what we're gonna do is we're gonna edit some sort of a file. So right here, inside of our Git bash prompt, all I'm going to do, does this have, yeah. So you can use whatever editor you want as long as you're in the directory that you just created. So I'm just going to open up something called file.txt. Just type in here, hello world, and then save it. This is just because I use now for the simplest of things. Okay. So now, yes. So all I did here was just create a file called file.txt and put something in. You can create, say, like a Python file. You can create whatever you want in this directory. But if you just want to, keep this simple, you can just do what editor showed you, the echo command as well.
Yeah, you show the echo.
Yeah. So there's also this thing you can do in Bash called echo. We'll put. So what this does is it just takes the text hello world and shoves it into file.txt. So
yeah, it's a one-line thing to you just have a couple of a few words to put into a text file. This is the thing to do. Mm-hmm. For people who have already opened random, did you figure out?
Oh, sorry.
Yeah.
I guess that is the time. Yeah, I went really fast. Yeah.
So by the end of this, you should have a file called file.txt or whatever you want in that same repository with some text.
If you're stuck in now, I apologize. Yeah. I can help you out.
Anyone else? No.
Oh, yep.
What's too late to do that?
Control X.
Control X, okay.
Sorry, that was a wrong call for me. Yeah.
So another useful bash command is cat. So it just quickly displays whatever is contained inside any file that you give it. So cat file.txt will show whatever the content is on it. Again, very useful if you have a very short, very small amount of content in the file.
Okay, so anybody not have some sort of new code on this inside this directory? Our code here is just something called file.txt. Yes.
So this is what your directory should look like. It should have the README file that you created when you made the repository, and the new file.txt.
Okay, so we all have some sort of text in here.
Yeah.
All right. So what we're going to do is we're going to add this file to what's called a staging area. So there's three sort of areas that happen locally. You'll notice this is all just locally on our computer here. We have the workspace where we just made this edit. Then we have the staging area. This is just saying what we actually want to save, and to actually tell what we want to save, we do git add and then the name of the file. So here's just file.txt. So go ahead and do that.
So you're moving things into a staging area
Good way to
before
do
you
this.
commit them. Git add file.txt.
And it might yell some things at you, but that's okay. All right, so now that it's been added, has everybody been able to do this? All right. So now it's been added, we're now going to commit it. So this is now the final stage of actually saving this file and telling it to contain this information. So it's just git commit. And I think the most important part here is you have to do this -m and then some sort of text inside of quotes here. So what this is doing is it's telling your repository some sort of title for this save state that you have. So in this case, just do -m and then say first commit or whatever other text that you want that describes this.
Goal is like each commit should have a brief description of what did you do in this version of the code.
So in this case, I could say like add txt or something like this. Yeah. What? It'll tell you
How long does it last? Until you read it?
Yes. There is a way.
Sorry, I just like. Is there a way I can?
Yes.
Sorry.
Yep, you're good.
I don't know actually.
No, you're good.
Even though my website is closed for every publication. Somehow that
All right, has anybody had any problems continuing? Any further questions?
Yeah.
All right, so just a small side note here as well is that now that you, for the first time, added this file.txt, say you start editing it again, you actually don't need to do both of these steps. If you want to add everything that you've previously changed in some future commit, you can use the -a option inside of this commit command here. So here, having -am will do both adding all the files that you've changed, as well as adding m, which includes making sure you have some text that goes along with your commit as well. So just to show that really quickly, I'm going to do, I'm going to say second line. I'm going to add this to file.txt. I'm going to show that it's in there. So now we have 2 lines in our text file. I just changed my text file again. And now if I git commit -am added second line. So now what this will do is it'll do both the git add for the file.txt, and it will also commit it with the message added second line. Okay. So you can see here that you actually have some information about this commit where it changed the file. You added 1 line here with 1 insertion, and it tells you, oh, here's the one we said that we actually added a second line with this guy. Any questions about this? Sure. Yes. What? No, he's not. Yeah. You have to add them. So you have to go through each time. You have to go through this entire process whenever you edit a file. Essentially, you have to add it to your staging area and then commit it. But the nice thing is that once you've added it for the first time, so you can now say edit a bunch of files, and then use this git commit -am, and it'll then save all the changes from all those files. Yeah. All right, so this is the git commit part of things. I'm just going to move on. So now we're, as Dia was just asking about, how do you check what's been staged, or how do you check what's been going on in your computer? Here's a couple of good commands that you can use. So the first one is git status. This will sort of tell you everything about what's happening in your repository at this very moment, such as if a file has been changed since you last committed something, if you've staged something and which files have been staged, if you've removed something, et cetera, et cetera. Yep, yeah, of course. So if I just type git status, it just says that my branch has had 2 commits recently. You can see that it's actually ahead of the origin is that online repository. It's saying that we're ahead of that by 2 commits because we made these 2 commits locally. And then it says another commit, right? Because we already committed all the changes that we made. So if I were to now, let's add a 3rd line, and then do git status. You'll see there's some extra information here, right? It says changes not staged or commit, and it says that it's hard to see in the red, but it says that we modify this file.txt. So this is just some extra information that you can get from this. So yeah.
Anyone still working on committing? Do you see anything when you get status?
Yeah. If people see git status stuff, is awesome. Unless you just added this 3rd file, so I'll just go through the steps here. So you git add file.txt again. I could show you the status. It's been added. So you say changes to be committed. It just tells you this information. So yeah, so add git add. All right, so just for the sake of time, we're going to skip over this git diff idea. This just lets you compare 2 files if you staged a file, you want to see how it compares to something you've previously done. It's a little bit more complicated, but this is at least here if you want to see it. Then also the other information here is git log. This will tell you all of the commits that you've made recently to your repository. Yeah.
Sorry?
What? For what? Like that?
Oh, next.
Oh, okay, cool. But if you just do git log, you'll see that my two recent commits here, where I added a second line and I added a third line, they're all listed in my git log. Oh, and also add file.txt in there, just a little bit further down. Yeah, I got it. Everybody set with these little things? Yeah, git status and git log are very helpful for seeing what you've been up to. All right. So finally, the last part of this little workflow is now we want to actually save those changes on GitHub itself. So everything's just been local. We just want to make sure we push, in this case, all of our changes to GitHub. So that's this command right here. So all you have to do is git push origin. This is saying push thing that you have to origin from here. This is our master branch. So this is just saying that right now we're working in master. That's just the default branch that it sets up when you initially clone, say your repository locally. So you're just saying push master and origin like that. So git push origin master. See what happens. Right. It might ask you to sign into your GitHub account, and that's normal if that happens. So
the push-pull terminology comes from the fact that the GitHub repository, the internet, is basically a GitHub cloud. So everything is above you, and you're pushing things up. And then when you need, you pull things in. So that is the idea of push. Just so that it makes it clear.
yes.
Because it doesn't know what you're responding to. So if you just capture other repository, actually all these slides are so you are telling kids that this is origin, this link is origin.
No, that's the thing about having architecture, right? Like, the journal does not like content the way that it is like, right? That's why archive are that you can take that idea at the same time and not display it in the way that right? It's like I know. That's my entire job. I think I'm oh my every time. So wrong. Like so ridiculous. Actually,
All right, has anybody not been able to push their changes to GitHub? So just so I can show you what it should look like now, my Kobe Spoon repository. You can see now that this file.txt is in there. You can see that the most recent commit to it, adding the third line, is listed. It was done 9 minutes ago, and I can even click on it in here, and you can see the actual lines that I've now made to this. Should I skip this? So just quickly, I'm not going to actually show you this, but if you say made some changes on GitHub, you could then pull those changes back locally. That's what that opposite command was here. We're not going to do that right now, just because of time. But it's just the opposite command of a push. So instead of if you make changes locally, you push it to origin, you can also pull changes that happen on origin locally. That's just the opposite here. All right, so now we're going to move on to this idea of branching, which I think is the one of the more critical ideas, especially if you want to take that next level with Git. So all the previous stuff, you can just do that on your own. You can commit your changes, push it onto GitHub, and that's great for your own personal repository. But what if you're like working with some other people, or say you have some complex code that needs to have a constant stable state, and you don't want to really mess that up over time? Bastian was talking about that a little bit earlier. So what we're going to do here is we're going to branch away. So we're going to essentially make a copy of our code and put it into a different sort of space, and then edit it, make whatever changes we want. And the original version of that code, this master branch here, will be unchanged. There's not going to be anything that happens to it while we're making all these other fun test changes. So the first thing you could do in your git bash here to do that is git checkout -b, and then name it whatever you want. Here's just called my branch. You can name it whatever you want right here. And this will then split it off and create your own branch separately. So I'm going to do that right here. Git checkout -b. Let's just call it branch 1 or something. All right, so it says switch to a new branch, branch 1. Pretty straightforward. If you want to check on your branches, you can see like where you happen to be right now, which branch that you're on, through the command git branch. Right here. Git branch shows we're on branch 1 right now, but there is also a branch called master that thankfully we're not doing anything. All right, so has everybody been able to check out and then see their list of branches? Any problems? All right, cool. So now, just to show you how branching works, I'm now going to add a fourth line to my file.txt here. So again, just moving fourth line into it. If we look at it, so it's doing the cat command here, file.txt. There we go. We now have our fourth line in our file.txt. So now I'm going to commit these changes. Whoops, sorry. Yeah. Thank you.
We are experimenting in a new environment. So when master branch is on track.
Yeah, I'll show that in just a second. Yeah, I'll show you what happens here. All right, so we've made the change that we wanted to make. Any questions with this? All right, so now going to git commit as am just for simplicity here, and add in a fourth line. All right. So now you can see in this commit action here, it says that we committed it to branch 1. So this is only occurring on branch 1. Nothing has happened on master. Everybody been able to commit their changes? I'll give you another minute. All right, so now that we've changed it on branch, what I'm gonna do is I'm gonna move back into the master branch and show you that it actually hasn't changed any. So this is this command here called git checkout master. So just like how we checked out my branch, the -b is just saying create a new branch that's called this. That's all the -b thing is saying. Now we're going to move back into the master branch, and so you use this checkout command here. So git checkout master. And again, just to show you what we're doing, I'll do git branch. So you'll see it's now listed. We are in the master branch. We're no longer in branch 1. All right, any questions so far? All right, now for the magic to happen. So now we're going to look at our file.txt. So doing this cat command right here, you'll see that the fourth line is not in there. So we were able to we were able to branch off into branch 1, create a fourth line, commit those changes, and then move back into the master branch. And look at that, fourth line is not in there. There you go. That's the idea of branching. This branch 1 is now doing its own thing, completely not affecting the master branch. Yes. No. You do not need to? No. So yeah, you can move between as many as you'd like, and it will change to whatever the state is of that branch itself. Yeah. Yep. So I can just to show you that real quick. Here we go. Checking out branch 2. You'll see. So I checked this out from the master branch. So if I look at file.txt here, it doesn't have that 4th line in there. So because I checked it out from the master branch, it's copying the master branch. So now that I'm in branch 2, I can just go straight to git checkout branch 1 and just move straight into branch 1. There we go. I'm now in branch 1. Does that make sense? Yep. Similarly, we know branch 1 has this 4th line. So if I do now from here, git checkout -b, let's call it branch 3. Now we're getting really complicated. And I look at file.txt, you'll see it includes that 4th line. So we checked it out from that first branch. It includes that information. All right, so that's the idea of branching. Yes, no question. It does not treat it any differently. It's just the convention with it. Yes, yeah, it's just the default name that it gives to it. Yeah. A lot of the normal different development teams do different things, but usually it's like the main code is actually in something else, usually called like deploy or develop or something like this. Yeah, the one that's like the one that people use is actually in that, and master might do something else. So it just depends on how you want to call it. Okay, so now let's say we made those changes in branch 1. What if we want to now say, oh, I like the changes that we made. It's all safe. It's all stable. Let's move those changes into the master branch. So now the master branch can have those changes in it as well. So this is going to be using the git merge command, right? Merge just does exactly what it says. It combines, it merges both your branch and the master. Yes. Sorry? So yes, I'll get to that in just a second. You're right. The idea of the merge, you have to be in the branch you want to essentially pull your merge into. Yes, that's very important here. So in this case, yep, I'll show you right here. You want to git checkout master, and then it would do git merge, and then whatever your branch name is. Yep, that's exactly it. Yes, I'll show you that in just a second. No, it's a really, really good question. Yep. Mm-hmm. All right, so just so you all see what I'm doing, I'm checking out master, going into the master branch, and I'm going to merge branch 1 into there. There we go. Yes, there's a question back there. Yeah, I'll show you that in just a second. Yeah, what will happen? Just give me a minute. There's another question over here. Yes. Yes, you would go into, say, branch 1, and you git merge branch 2. And that would move branch 2 into branch 1. Yes, yeah, always pulling in merges, essentially. Yes, it'll be branch 1, so it'll change branch 1.
Yeah.
Yes. Yes. Branch 1, yes, still exists.
And branch 3
Yes, it will.
well, yeah,
Whenever you merge, all you're doing is just say, take the change that's in this branch and modify whatever branch I'm in right now to change. The original changes in that branch will still be there. You can still check it out again and keep developing or something in there. No matter which branch it's in.
Yeah.
So polling is an operation between the internet so actually this is an interesting question. So I just have a question is what is the difference between a git pull and a git merge? So pull is the operation that goes between GitHub and your local workspace. And actually git pull does two commands in one. I think I might have a slide on this as well. It's doing git fetch and git merge in one command. Git fetch is just saying download the things from online, put them somewhere on my computer, but I won't actually be able to reach them. And then git merge, it takes that little like saved repository and then merges it into git pull just combines those two operations into one. So it does so git merge, git pull is a subset of git merge. All right. So yeah, we get checkout master, we get merge branch one, and now if we check out or we look at file.txt, you'll see that the fourth line in there. And as well, if I do git log, you'll see that this added fourth line includes both the master branch and branch one in there. So just you can look at like the git log and get lots of crazy information about what is actually where these actions actually happen. Okay. So everybody was able to merge their branch into their master branch. Any further questions about that? So the other small thing that I can mention here is that say you're working on your branch and then say you need to go do something else for a while, but you know that your branch is not in a place that you can put it into master. Interfacing with GitHub is exactly the same. It's just that instead of using master, you just use whatever the name of your branch is to push and pull these changes, and it'll just keep the branch in place. It'll just save whatever's happening on your branch online. So instead of doing git push origin master, you do git push origin and then whatever branch you want to be saving back and forth. We don't need to do this, just a little side note here. Okay. So that's essentially the workflow of Git. So you can, I think, hopefully you have at least a basic idea of adding things to your staging area, then committing those changes, branching off, doing your own thing separate, and then merging those changes back into your master branch. So one of the important things that I also want to mention here is this idea of a pull request. So merging is really great if you're just working on your own code and you know that everything is working properly. But with a pull request, it allows you to sort of distribute some of that some of the risk that goes along with merging some of these changes. So let's say you now pushed your branch into GitHub, and then you want to merge the changes. What you do is you do this, open a pull request, and this will then go through the merging process, but in a safer way to show you what all the changes that have been made. It allows, if you're collaborating with other people on your project, it allows them to check the changes as well. And so yeah, you get a lot of extra information by doing it this way. But all this is doing, even though it's called a pull request, is this is doing a merge just on GitHub itself. So I should be able to show this. So, let's do git checkout. Okay, so I just pushed some changes. I'm going to check out branch one. Now I'm going to add a fifth line because this is the amazing code that we're writing right now. All right, we check that this is in file.txt. There it is, 5th line. I'm going to now commit these changes. Sorry if I'm going fast, but okay. So now I'm going to do just what I said here, git push origin branch. Okay, so I just made some changes on my branch. I committed those changes here. So I added this 5th line. Now I'm going to push these changes to GitHub. It connects to the internet. There it goes. All right. So now we go into GitHub. We can refresh the page. Let's go back here. All right, and you'll see that branch 1, less than a minute ago, had some changes, and it says, oh, you can compare and pull requests. So I'm just going to go ahead and click on here.
That only shows right after you update.
So yeah, it will just show this. Yes, it will just show this right after you update it. So if you can also do new pull requests here if it's not there. Yeah. So there's this new pull request thing. We can actually just click on that. So here you'll say, okay, so from we want to put branch 1 into master right here. So there's these 2 boxes right here. So master is where we want to put stuff into. Branch 1 is where we want to take it from. It'll auto fill in some information, but we can of course change any of this. Have some extra description in there as well. And then just create the pull request. So all this is doing is just essentially the merge, but through an online interface. All right, and what's cool about this, answering Thea's question from before, is this is a great way to also have fix if there's any merge problems. So say you made some changes on master and you want to move some stuff in, but you happen to make the same changes on both of them. Doing this through the pull request makes this actually really nice and easy because it gives you a visual interface to say, oh, there's some problems on here. Click this button to fix them. And it'll then show you the actual code itself, and it'll tell you, here's code from the master branch, here's code from your branch that you created, choose one of them, essentially. And then you just delete everything that you don't want to use between them. It does do this locally as well. It's just a little bit more complicated to go into the file itself and then change it, and this just gives a nice visual representation of what exactly is going on. So yeah, if there's a problem, this will come up with like a red or a yellow type thing, and you'll be able to then click on it. But then we said it's all good, so we're just going to confirm this merge, and voila, pull request successfully merged and closed. There we go. All right. Anybody have questions about pull requests? Yes. Yes, that would be good. Okay. So this is actually also a good time for me to show you how you can also do things on GitHub if you wanted to. So here's our main page here. I'm on the master branch. Let's move over to, say, branch 1. So that's just clicking this button over here. Now we're on branch 1. So now I click on file.txt. It actually comes up to a text representation on here. And if I just click this edit this file, I can actually edit code or whatever else on GitHub itself. So just this little pen right here. How did I get there? Yeah, so I can show this again. Yeah, so going back to the main page, there's this button right here that says branch. Yep, and then you just click on branch 1. Yep. All right, so I'm just going to edit this file and do something like, oops, what happened? Lost it. All right, so just so you all can see what I'm doing, I just changed one of the lines in here. I just called it secondary line. But you can also delete stuff in here, yeah. Sure. like this. Sure. So now there's no more fourth line. I'm just trying to get a merge conflict to happen, which is sometimes hard to do. So now I'm just going to commit these changes that I just made directly on here. It's just a nice form that you can do this here. All right, so we made these changes in our branch. Now I'm going to move back into the master branch. You'll see that these changes were not made here, right? So that's the same as it was before. Nothing's changed. But now let's actually edit this file and let's call it. Let's see if this works. Call it like the second-ish line. Again, committing these changes. Okay, so now we have two versions of this second line, both in the master branch and in the branch that we made. So let's see if we actually created a git merge problem. So let's go back to our main page here. Let's open a new pull request. Let's go from branch 1. Yes, so here we go. So it actually shows up even right here, right away. It says can't automatically merge, but it says don't worry because you can still create this pull request. So let's see what this looks like. All right. Anybody who's trying to follow along, do you understand everything that I've done up to this point? Any questions? Sorry. Yes, we can also do that. Yeah. The changes are like the merge problems. Okay. Yes, we should be able to do that. Well, so the case is that it'll be very similar, and we are running a little short on time. But I'd be happy to show you maybe like during a quick break. We can do stuff like that. Yeah. Okay. So I'm going to go ahead and create this pull request. Okay. So here we see that the branch has conflicts and they need to be resolved. So it's actually not allowing us to even merge these changes right now. We're not even allowed to finish this. So if we just click on this resolve conflicts. All right, so here's what it'll look like. So in the case of if we're doing this locally, going back to your question, what would happen is these same things would happen. You would type git merge branch 1 and it'd say there's been a problem. Please check out or please look at file.txt because we've created this like auto merge case. And so right here, all it's doing is it's just opening up the file.txt file and then asking us to make the changes there manually. So if you were to do this locally, it would you just have to go to file.txt and make this change before the merge could actually be completed. So here we see branch 1 says second-er line, and the master branch says second-ish line. So all we do is we just select which one we actually want to keep. So here I'm going to keep the second-er line. So all I did was just delete all this extra fluff that was around there, just saying this is in branch 1 versus the master branch, and just keep the second-er line in here. This is the one that we actually want. And then mark it as resolved. Oop. It says, great, good job, you fixed all the problems that we found, and then it allows us to commit the merge. Yes? So fourth line doesn't show up because that was a change that we made in branch 1 that wasn't simultaneously changed in the master branch. Yeah. So by deleting the line there, it recognizes that is a unique change that only happened on the branch. Yeah. So yeah, so it's pretty smart in terms of figuring out what you actually do these days. Okay, any questions about these merge conflicts? Because now I could just commit it.
Visualize all of the changes, even the ones that aren't like highlight.
Yeah, so that's what's called git diff, and they also GitHub is really nice about that as well. So let's see if I can do this. So if I just go into file.txt, you can actually also do, shoot, where is it? Yeah. No, so this is yeah. Okay, so this is the last little bit of thing. Yeah. I'm trying to. I don't know if I can find it right now, but yes, on here, what happens is on some files, you can do, there's like a button that says diff. I'm just missing where it is right now. Yeah, so under history is great. It's just like git log. This shows you what actually happened in the past. So actually, if we go to this one, perhaps it will, yeah. So this is essentially what it looks like. It'll show you what happened in this commit that actually made this change. Yeah. It'll show you both files. So there's the initial file, here's the final file, here's what the difference is between them. Yep. So yeah, GitHub's a powerful tool for being able to check out what your code is and what it looks like. All right, so in the interest of time, we're now going to take a quick break so we can have some mental, relaxation for a little bit. Let's try to come back in about 10 minutes so we can get to some of the more advanced topics with Ishan. In the meantime, feel free to come up and talk with us if you have any questions about what we've already discussed. We'd be happy to help you out. Awesome material. Trying to think of a good place to show this to you. Go back in there and so one thing you can do is if you go to a branch itself, and click on the branch, compare, right here. There it is. That's what I was looking for. So if you just do compare, you can compare branch 1 to master, and it'll then show you what all the files look like here, and then a little bit further down. It'll show you the difference.
Okay, so how is it going to show you the master on the left and what's the other? Is that just the default?
It's right here. So you can choose master.
So you're at the branch, and then you choose that.
Yeah.
Yeah.
So there is sort of a way. So this is the other routine. So you have yeah.
any so if I don't feel like I really is there a way to do that?
Yeah. Other Python package with we need to get through the code accessibility and user perspective because it's just the list of material that is on the repository.
Because I want some time for the website thing, because I think that is also something that they can do because it's very easy.
Yeah, I was thinking of also talking about forking because I think that's another important thing. Perhaps just showing how it's done. I don't know. If not, that's fine. Me too.
I think we are. It's no.
What are you trying to do, sorry?
No, are you trying to find the repository?
Yeah, I'm just getting to the.
So I think it's on. It's
Yeah, it's the first tab. Oh
no, this is the code display one.
I think we just closed.
yeah, we done something like that. So just put a new tab.
Actually, just
Yeah, there it is.
I think what else is in here?
You can actually just mention that okay, there is a documentation there because I'm going to be talking about that, so we can just
Yeah,
whatever.
that's fine. That's fine. That's fine. Nice. Great.
I didn't know it. No, we gotta go. Good idea. That's good. Version control is great.
Yeah.
Yeah, especially how the writing changes.
No, it's very helpful. And, yeah.
Well, they share like that. Yeah, yeah. I used to use share like that now. Yeah, they already have it. Yeah.
Everybody back in.
Yeah, I was like,
All right, so everybody, as everybody's shuffling in, just want to let you know that there is, like I said, like we said, these slides are on this GitHub repo. So like here's a nice summary page that if you ever get stuck and you want to remember, oh, how did I do that in our session? There's just a nice overview like this. You know, things cloning, adding, committing, checking out branches, and then pushing and pulling to our GitHub repository. All right, so to start off this second part of the session, We're going to be talking just very briefly about some best practices for both code accessibility and documentation. These just sort of how to make sure that not only is the code good for your own personal use, but also if other people want to be looking at it, whether it be collaborators or say, as you've seen some people in the talk, posted their code on GitHub so other people can just use it and that sort of thing. So just some general ideas about what to do and how to do it. So first off, one of the best things is we just talked about these Git commit messages. Just making sure that they're properly formatted and have the proper information in there. That way, if you ever have some major problem, you can always look back at your Git log, at your Git commit history, and see all the changes that you made over time, and then you might be able to figure out, oh, that's probably where this bug sort of came in place, was from this place. It also allows you that if you're, say, merging your own changes into somebody else's code, they can look through your commit history and say, oh, they made these sorts of changes to my code. This looks good, or this thing actually breaks something critical. We probably shouldn't merge these changes. It's very important to have these sort of really nice commit messages. So if you're on our GitHub repo, there's actually a website here that shows you some good ways to actually format it. Another really important resource here is GitHub's issue tracker, which is extremely useful. So I'm going to actually show you this very briefly up here. So if you look at the very top, there's this tab here called Issues. So if you just click on this, it brings you to a page that allows you to sort of bring up bug problems, or if there's like a new enhancement that you want to add later on, stuff like this. So you can just click on New Issue, and then put it whatever you want in here. So we can just say like add some web page. We're going to be doing that in just a little bit. The same later on, we should web page, and then you can assign certain people to it. So I just assigned Sean to do this. He'll be doing that in a little bit. You can add labels to this, such as like if it's a bug, if it's some sort of an enhancement, some sort of a first issue, things like this. You can create a new label if you wanted to. So we're just going to call this enhancement, and various other things like this. So then you can submit this issue, and now it'll show up on our issues list. There it is. So you might have seen this sometimes when doing like, you hit some bug with somebody else's code. It might have brought you to a GitHub web page that had some people talking about this in like a forum. This is exactly what this is. This is the Issues tab on GitHub. So now, later on, it'll show you, okay, here's what the initial issue was, and then anybody can now come in and like leave comments and discuss this issue and figure out ways that you can actually solve this further down. And once it's fixed, you can then close the issue. So the issue tracker is really great. Again, there's a link to more information about that in this GitHub repository. Scrolling down here. As well, we also have some resources for good practices with documentation. So Sean's going to show you some of these things a little bit later on in practice, but just so you know, all this information is here. This is just the idea of when you write a new file, what sort of information should you contain at the top of this file to say what it does. Whenever you create a new function, say in your code, how should you actually probably document that, or a new class in your code? How should you explain what is actually going into and out of that code? That way, this is really, really important, not just for other people looking at your code, but as I've realized over the years of programming, that I forget what I've done, even just a few months after I've done it. So this is, I think, very important just to get in the regular practice of doing it. Here's some great websites to show you some good ideas, some good places to start with it. Just get it into your normal programming routine really tonight. And also, sort of similar to that, I really love this website, Google's open source style guide. So Google just has a nice resource that shows you for most programming languages that at least we would be using, what are good ways to style the code so that way it's as easily readable by other people as possible. It's a great way that if you're confused, like what should I name my variable or what should I name my class, stuff like this, it's a good place to start to see, oh, what does Google do with their open source projects? And it's a really, really clean sort of guide for The final thing on here is also this packaging your Python project. Here's the link to it. Sean's going to be sort of giving you the introduction to this in just a couple of minutes. All right, so these are just some of the ideas. Any questions about any of that? Cool. So yeah, make sure to document your code. It looks great.
Okay, so as Ryan said, I'm going to give a brief example. So you don't have to work along because this is a 4-hour workshop compressed into half an hour. And so what I'll do is I'll just, the idea is a lot of us work with Python, and we have these Python scripts or Jupyter notebooks where we have some data, we have to do some analysis on the data. What if you want to make a library out of the functions that you use, and you want to push it up to GitHub, you want to make it well documented, you want to create a documentation website for it, and you also want to make the set up continuous integration, which Brian briefly mentioned. So continuous integration is basically something that tracks whether there are any conflicts in your code. So in Python, there is a very nice thing called PyTest, which basically, if you have set up a bunch of test functions for your code, then it will run the test functions and see whether everything is okay. So tests for functions are basically tests that check whether everything is okay, because you will be making a lot of changes to your code, you will be making changes to the function, but they should be doing what they're supposed to do from like throughout the history of the development. And so these tests will make sure that they're doing that, and they'll let you know, okay, which function is failing for whenever you make some changes. So I'll go over everything, and it's written down in this document that I'll be just that we'll just follow. Just move this here. Cool. So what do we have? So first of all, like, yeah, all of the stuff that I'll be showing is borrowed from this workshop that I attended in AGU last fall, and they have their own repository that I've linked. It's an excellent workshop. They have a 4-hour video screencast of it on YouTube. If you are interested in anything like that, I would highly recommend checking their stuff out. These are people who have been developing for years. They are experts, seasoned developers, and so they have a very well put together workshop content, and you can always contact them for any issues you might have. Anyway, so what is the motivation for doing what we are going to do, and like whatever conventions we are going to follow? Is to make the code easily reusable. So it's important for you to have, so if, for example, if you have functions, you can use these functions for multiple data analysis instead of copy pasting your code everywhere. We know that. Then make the code robust. The testing things that I talked about, if you create tests for your function, then they'll be robust against any changes. Like, you'll know immediately if any of your changes make the functions not do what they're supposed to do. And then make the code version controlled. So that is where Git and GitHub come in. Make the code easily collaborative. Again, GitHub. Sharing it with people, and if you have well-documented code, then it makes it easier for your collaborators to understand what you're doing. And that's the last point. So here's what we are starting with. So if we have a Jupyter notebook, how many people are not familiar with Jupyter notebooks? Okay, so Jupyter notebooks are these tools. It's a tool which incorporates code and text, which is written in Markdown, by the way, into one file. And so you have cells which has code, and then you can create a new cell which will contain text, so you can document the code as you go along. So this is like, it's called a computational essay in some way. And so you will see in a lot of Python packages online, people provide examples of how to use their code in the form of Jupyter notebooks, because they explain what is happening exactly as you're doing at the steps. And so it's very, very useful to, when you're developing your code, to write down stuff and to document what you're doing. And so here what's happening is that we are downloading. So this is again borrowed from that AGU workshop. So here we are downloading a data of surface temperature anomaly over Australia in the past 100 years. So this is hosted on this website called Berkeley Earth. So you're downloading that data, and then you are saving it into NumPy, and so you're downloading the data from the website, you're saving it into a NumPy array, and here it's just converting the year and month into a decimal number so that you can find. So for example, year 1880 and month 6 would be 1880.5. And then you're plotting the thing. Okay, here's you're plotting it, but the main crux of this analysis is this function called moving average, which is basically taking a window of your defined size, sliding it across the data, and creating a smooth curve. So you're averaging in that window. And so, for example, if you do that, so this is the data, and the orange line is the 12-month moving average. So you are moving in the window of 6 months at a time, 12 months at a time, and you're averaging it as you move on data. Great. So this is what we have done. Simple. We're doing very simple stuff here. We're downloading data, and we're applying a simple function to it, which averages the data with a defined window size. Okay. So now that we have this, we will first refactor our notebook or code to make it more reusable, readable, and in some ways just like more elegant. And so that is called refactoring. So the first thing that is recommended is that you should avoid using local data. So for example, these guys, they download the data directly from the website. So if you have access to a text file or anything, that file that is available online, do that. If not, and if it's a very big file, then have a script that checks your local directory to see if that file is present. Otherwise, it goes to that link and downloads it. So the idea is that your GitHub repository will have the code. It will not necessarily have the data, because what if the data file is like a couple of gigabytes big, right? And so you need to make sure that whoever is using your code doesn't have to struggle to find the data. And so if it's available online, your Python script should in itself go online and fetch that data for it. So that is one thing. They're already doing it here. Refactor the code to use functions. So in the original script, we had a cell that was getting the data. We had a cell that was doing the moving average, but we would like to make it reusable. What if we want to do the same kind of analysis on a different set of data? So we will turn everything into a function. So you get a function that will get the URL. So here, the URL is such that you just change the country and it will give you a different country's data. So they create a function for that. Then you use that URL and it just uses the country and it can get you the data and returns a data array. And then you also create a function to, to convert the year into decimal year. That's not important, that's just for plotting. But the main thing is that moving average. You create a function to do the moving average. So every kind of analysis that you perform has been converted into a function. So now that you have this, within this notebook, if you want to do any other analysis on any other data set, you can just use these functions and you'll be good. Like basically, all you have to do is just do a moving average function here, and you can repeat it for any kind of data in just like a couple of lines. So you know all of this, but this is the way you progress from a very rough, undocumented script to a publishable package. The first step is to make everything a function, increases reusability. Then the stuff that I was talking about, which a lot of us don't do, is create tests for function. So that is done with something in Python called assert. So what assert does, it just tests whether all of this is true. And if it's true, so if whatever you have here is true, it will do nothing. And if it's false, it will just say that, okay, there was a problem, or I encountered a false value. What NumPy.all is doing is basically it's just checking whether everything, there's an array being returned here, all the elements should be true in that. If there is even one false, then we don't accept that. Then we will return false. So what's happening here is that you are doing a moving average of an array of ones with a window size of 4. And you are just checking whether the second last element are equal to 1. So I can just, it's difficult to understand this. I'll just show in a very quick example what's exactly going on here. So okay, wait. So I have already install the package. We are going to do that later, but just to show you guys. I'm sorry. So we are doing a moving average on an array of ones with a window size of 4, right? Not used to doing this with the command line. Anyway, so this is what's happening, right? So it has an array of ones. It takes us to the way the function is defined. It moves the window so that it fits completely. So window size of 1 here, and so it will first fit completely when it's here, because the window, so it's like 1, 1, 2, 3, 4. So it will do the value here, but because you initialize the array with none, it doesn't really output anything on the other side. So the point is basically you know what an output for a very simple case of all an array consisting of all ones should look like, and you just give it a test that okay, check that all the elements from the second position to the -2 position are equal to 1. That is exactly what that assert test is doing. It's checking that okay, I did this analysis, and all the elements from the second to the second last position should be equal to 1. So this will return a true array, and that will and that will basically add. So the assert will get a true value, and your test is passing. So I will later show if you mess up the code what it does, but that's the point. Like you create the simple test of the for the function. Like you know for a very simple case what's going to happen. You make this assertion that yes, if my when I'm doing this analysis and doing this computation, this should be the answer. And if it's not true, then something is wrong with it. Something wrong with your function. So make tests for the function. I've done some more details, but let's just move on. So yeah, I just talk about what assert does, as I just mentioned. And so okay, so you have functions. You have created tests for the functions. But what if you want to use these functions in different Jupyter notebooks or in different scripts, right? It will be a good idea to move these functions into a separate Python module of their own that you can import, just like I did on my command line because I've already done this step. So what you do is let me just close this. You move all the functions to a separate file called data-analysis.py. So this is what my repository currently looks like. Like if I'm uploading everything on GitHub as we go, like that is happening in the background. So we started with a Python notebook, right? That had all the script. Then we converted that the functions in the whatever we're doing in the script into functions. And now we want to use those functions as usable as possible, make those functions as usable as possible. So we moved all those functions into a data analysis.py. By the way, stop me anytime if you have questions, because there'll be a lot of stuff I'll be talking about in like 20 minutes. So yeah. Okay, so data analysis.py. So we have all the functions here that our script uses. Download data, extract monthly anomaly, and the most important thing, which is the moving average. And because I'm focusing on that because this is what we have a test for, and we also define a test function for it. This is the test function, so it does the same thing, that it's asserting that this condition should be true. If it's not, your function is not. And why this format? Why test moving average? So as I will later show, there is a function called test, which if you run it on your directory, it will go look for every function that starts with test underscore, and it will run it. And if any of them fail, it will tell you, okay, this has failed. And so you know that if something happened with some one of the functions, that you can go back and check it. So this is the convention of making test functions. You do it with test underscore. So this is what we have right now. We have created a Python module. Python module is basically any Python file that has some functions and some classes, basically anything that you can import. And the key point here is to, like, okay, you have created this file with all these functions, but now you have to document it. So I have, oh, by the way, in my the whatever I'm talking about in the text thing, I have mentioned a lot of takeaways. So those are the important things that I want you to take away from this discussion. You can go back and look at them later. I also summarize them at the end. But so the takeaway here is that put a docstring at the top of the module. So a docstring is basically the format of a Python docstring is 3 quotations at the top, 3 quotations at the bottom, and then you write something here. And the reason you have this strict three quotes convention is because, as we later see, there are some Python packages that will automatically go through your folder, look for all the modules and functions, and create a documentation out of it. And what the documentation is that they fetch for each function is this docstring. So, for example, you can do a build of URL to data or whatever they are doing there. For moving average, we have we have calculating a moving average over 1D data using a given window size. And the best example, Brian already pointed out great resources for a docstring, so you can do that. And I would highly recommend going and looking at well-established Python packages code. So for example, if you go at numpy.mean, the mean function, it will, should be loading. So this is the GitHub repository of NumPy where all the code is. And this is the mean function, and look at this docstring. It's so well documented. That is one of the reasons that Python is so popular, because documentation is very, very good. So this is what you should be aiming for when you are doing your own documentations. You tell what the code is doing, you specify the parameters and what they are, maybe a version if you are at that stage, and what it returns, and then maybe C also. This is what you see when you Google for Python's documentation, right? You might have seen this thing come up in Python's doc pages. It's basically the doc pages were constructed out of these docstrings. And so this is what you are seeing. So yeah, very important to have docstrings on your functions. One line of description, description of what the parameters are, and description of what it returns. Standard. Great. So that's what we have here. We so we have a data analysis.py module which has a list of functions. They are well documented. Now we want to make this a proper package that you can install, that anyone can install from pip, or and we can also upload it on GitHub and share it with others. So at this point, or you can have also done it before, you put everything on GitHub. And when you're doing on GitHub, if you are publishing a package, there are certain things that you want to do. First of all, it's very good idea to initialize everything with a README, as we have told before. But for Python packages, the README has a certain format. So first you tell, okay, what is this about? What does this package do that you are putting up on GitHub? How do you install it? We fill all of these. So I will start usage, examples of what the library does. So, and then you initialize with a gitignore file. So remember I told you that gitignore will become important when you are actually making packages. So what happens here is that when you when you're creating a new module, you'll get an option to add a package. So if you already have a GitHub repository for this, and like for example, if you have been pushing things on the GitHub repository from the very start, and you never bothered to create a git to ignore file, you can just create one. You can just create a new file and do .gitignore. But if you're creating a new repository at this point, Python gives you an option, and here if you click down, you'll get an option of Python. So GitHub already has a default file for every programming language, and it knows, okay, which are the files that are not necessary to track. So for example, if you look at our repository here, it has a gitignore file that, let me go there. So currently we have, as I said, we have data analysis, and we have this gitignore, and this gitignore, this is all default. This has all been provided by GitHub. It contains a lot of these extensions that are created whenever you run your Python package, or whenever someone runs a Python package, and this doesn't really need to be tracked. And so Git will just ignore it. These kind of files won't be tracked. For example, if you are using Jupyter Notebook, if you have used Jupyter Notebooks, they create something called ITYMB checkpoints. So the Jupyter Notebook will create checkpoints, which is basically they'll save the last time you manually click the save button on the Jupyter Notebook. They'll save a version for it. It's like Jupyter Notebook's own volume control thing. But you don't really need that with Git, because Git is doing version control for you. So that will be included here, that, okay, include all the ITYMB checkpoint files. So that is the list of git ignore files. And then you add the git ignore, you added the license, and oh no, okay, no, I did not talk about license. Sorry, you added the README, then you add a license. So here there was another option of choosing a license. There are multiple licenses available online. All your job is to include one. The most standard one is the MIT license, which basically means that people can do almost anything they want with your project, including to make and distribute closed source versions. So this means that you're granting everyone the access to use their code as they wish, as long as they cite you. And it's an important thing to put, because people don't realize, people think that putting the license in means it's your copyright. It's actually the other way around. If you don't put a license in your repository, it means that it's copyrighted by you. So if anyone uses that code, it can create a lot of problems later. So always make sure that you have a license if you are publishing a package on your repository. And MIT license is a good way to go. There are multiple websites, and certainly this one that talks about different licenses. The lesson is that don't write your own license. They are legal documents, and it's just not a good idea for you to try to become a lawyer. And so we added a license, and there is something else that you add, which is called a code of conduct file and a contributing guide. So a code of conduct file is just this. It just says that this is the code we established for people participating in this repository or working along with us. You will use welcoming and inclusive language. You will be respectful of each other's viewpoints and experiences. No discrimination and stuff like that. So you establish a code of conduct for your project, and this is another very important thing to include in your repository. And in the same spirit, you can also include a contributing guide, which basically tells the contributors, okay, what are we expecting you to do, or what are the right ways of doing it. This can get more into the specifics of what the package does and stuff. So for most of the people, just put this, we accept something. So I've talked about a lot of things. I'll just take a minute and recap everything we have done and what our repository looks like. We started with a Python notebook. It had some code which downloaded data and did some analysis on it. We decided that, okay, to make this code more reusable, we like to convert these into functions and document those functions, create text for those functions,
and put everything into a module of its own, data analysis.py. So that you just import data analysis and you will get all the functions. Then you create, then you push everything to GitHub. It requires a README, which is here, which gives a brief description of the package. You include a license that dictates how this code is supposed to be used. A contributing guide for the contributing if you want them to follow its guidelines. Code of conduct, establish the kind of working environment you want with this repository, and then a Git ignore file specific for the language that you are using here so that Git does not keep track of unnecessary files. Any questions at this point? You know, this is a lot to take, but everything is on here again. You can go back and look at it at your own leisure. Questions? Okay, I'll move ahead. Great. So you have this data analysis.py file. Now you want to make it installable so that anyone who downloads it, they can install it and put it in their Python path. So you don't have to be in that directory to use that data analysis.py folder. You can be anywhere on your computer, and you can just do import data analysis, and it will come up. And so the way you do it is you add something called init.py into the data analysis folder. So let me go and just show this example. I think that will be the easiest way to do it. So remember, so what we did was we just moved the Jupyter notebook into the examples folder, so that we want to keep the examples separate, so people can go in there and look at some rough calculations that we had done before. But in data analysis folder, now we have this init.py document. It is blank, it has nothing. But what this does is, init.py tells Python that okay, this folder is a package. So all the things here are modules, and this package can be installed. And so this format is called, so it's $init_.py, and this is called dunder variable. So that's something that Python uses, and it looks for, it knows these things, if these things are present, then what it's supposed to do, and _init_ is one of this. So dunder is double underscore basically. Okay, so we have set up an init.py file. So if someone wants to install this module, they'll know that if someone is looking to install a module in this directory, they'll know, okay, this is the mod, this is the package that you want to install. And how exactly do you go about installing it? So there is something called setup.py. What it does, it just gives a setup for all the packages that are present in your directory. So when anyone is installing it, basically how you install packages, you click install something. Right? So what guidelines should that installer follow when it's installing packages? So this is all. So here we are only provided one setup. So you only see one setup because we have one package in this directory. Data analysis, we have multiple packages. You would create this documentation for every package. And so you say that, okay, the name of the package is data analysis, the version is very first version, 0.0.1, give a description. Install requires, you tell the installer that, okay, before you install this package, it requires NumPy and requests to run it. So you should make sure that these exist first before you install the package. Some other description, if you want to put a URL, and then also some other classified programming language and license and stuff like that. It can go on and on. There are multiple things that you can fill in here. So once you have this, the idea is that the installation becomes straightforward. So what you do is you just, if you are in this folder, you just do pip install -e dot. So dot is just indicating that we are in the present folder. But pip install will, what does pip install do? It, whatever directory you feed it into, dot means current directory. You could just put any directory here. It will go into that directory. It will look for any init.py files. And if it finds init.py files in any folders, it will assume that, okay, this is a package and I have to install it. Now, how do I know
like what is the convention of installing it, it will go back to the setup.py in the root directory and look at whatever configurations we have defined and install it accordingly. And so that is what we do here is we include that installation instruction. Wait, where did it go? Yeah, sorry. We include that installation instruction in this. So anyone who wants to install your repository, what they will do is they will clone your repository, right? And then they will go into the directory, and then they will pip install -c dot, which means that pip will look for packages to install in this directory. What is -c? -c means that the installation is editable. What it basically means is that instead of copying the package as it is and putting it into the Python folder, which exists in your C drive if you are using Windows, it will create a link to that folder. So basically, like it will take the latest version of the code, right? If you're making any changes, that will be that is what will be imported when you are importing this function. So what I showed you here when I was doing my package thing is I have already done that step for my local PC. And so when I do this thing, import data and start functions, it has already been installed in my computer, and so it can import it, right? So you have put in the installation instructions here. Great. It's a lot of fun. Anyway, okay, we are getting closer to creating a good, solid Python package. And so we have all these auxiliary files that are specific for the repository. We have a setup of file that will help pip install your package properly. Data analysis package. Examples is just a separate folder that contains whatever notebooks or anything you want people to refer to if they want any help. Then the thing is to incorporate testing into your repository. Like, how will you know that whatever changes people are making or you are making is not breaking down everything, right? So I have been talking about PyTest again and again, and now I'll show you what it does. So I exit my repository. I am in my repository. So if I look at it, it has all the things. So it has some more things that we'll get to later, but it has this data analysis folder that has the functions.py functions.py file. And it also, if I move into data analysis, it also has something called test data analysis.py. So what I have done basically is, if you look here, I think that they will also have it. Oh no, they won't include it. You move all the tests that you have for every function into a new file of its own. So now your data analysis has a test data analysis.py folder file. So because the reason you do it, this is a very simple example. In packages like NumPy or SciPy, there are hundreds of thousands of tests. So having all of them in one file is much simpler than having them scattered across multiple packages, right? So you just create this test data analysis.py folder and you put all your tests in there. And so when you run a function that looks for test files, it will just find this file and it will go into it and run all the test functions. Again, a convention to make things easier and more accessible so that people can immediately see what are all your test functions. So my local repository, which is basically the same thing, also has that. So if I go back and if I do PyTest is a package that, and as I said, look for any functions or modules starting with test underscore and perform all the and run all the functions that are there, right? So if I run PyTest, it's saying test session starts, collecting 0 items. It says, okay, you have passed one test. Everything is good and fine. Now, what if I break my code, right? Let me do that on purpose. So, CD data analysis, or I'll not. Okay, yeah, I'll break my code. So, yeah, right. I think that's okay. And, okay, so we have this function, which we are testing, the merging function, and I'll just do something silly here that I will. So the average value that it's calculated is basically an NP mean function, but I'll just add some random thing to it. I'll add it to. So our test is looking for, our test is taking an average of an array of ones. So that should return an array of ones because you're taking an average of number of ones of any window size. But because I have made this addition that, okay, now average will have any mean that you have +2. So the test will fail because the test is looking for all ones, right? Control X. Yes, so I've made this change. I'll go back and I'll do the same thing. My test. It tells you that, okay, something went wrong. Assertion error. You could not satisfy the assertion condition and there is something wrong. It's not equal to, well, our tolerance means that it's not exactly checking if they are equal because there are floating point efficient creates differences. It checks with them two within a tolerance. So the tolerance is number. And that is not important. The important thing is that, yeah, the test failed, right? So this is a very powerful thing. Imagine if you're creating some big package or you're working on a super big project that has hundreds of functions. Changing, and functions usually depend on each other, right? And so breaking one thing can break a lot of other things. And finding that can be a pain. And so this, and also you will not be, most people don't usually use Jupyter notebooks. And so, I mean, Jupyter notebook is easy, but this still provides you a very kind of well-defined way of seeing that, okay, your code, the changes you have made has not broken down everything. Your code is still doing what it's supposed to do. Your moving average function is still doing the, providing the right answers. And so great, we would like, so now that we have a repository, now that we have a repository, we would like this test to be done again and again, right? Suppose you're working with 10, 100 people. Someone uploads something, you have multiple contributors. Multiple contributors means that they can just merge on their own. They don't need to create a pull request and have someone else approve their merging. So, or you are just managing things on your own. If you want to run a test, you will have to download this code on your computer and then run the test to make sure everything is okay, right? It will be much easier if something can just run these tests online for you as soon as you make a change. Do people understand the importance of this? Because it's difficult. Some other collaborator has made a change. Now, who has the authority to create a test? Like, who has a job to make sure that everything is working? So, like, it's a very difficult thing to manage. So, if some external automated system is doing the test continuously for you, life will be much easier. That is where some services come in, and I will talk about it very, very briefly. So, wait, where did it go? Yeah, here. So there is something called Travis CI. So Travis CI is a package that Travis CI is a website that links to your GitHub repository. You tell it what functions to run, and it runs that every time you have a change in your repository. For example, this is my final version of the repository that I have. So I will directly show you what Travis CI is doing. So all you need to do for Travis CI is you link your repository to it, and you put something called travis.yml file in this. This is a configuration file for Travis. So Travis, when Travis will look into your repository, it will try to find this file that has its name in it. And this is what you wanted to do. Very simple text. You wanted to set up the language Python. You wanted to have Python version 3.6. You wanted to do this. So it installs your package first, and then you wanted to run this. Right? So Travis is linked to your account. It keeps checking your account to see if there are any changes. As soon as there are any changes, it basically does what we tell it to do in this Travis.yml. And so if you look here, it's basically doing that. So it's saying that, okay, it has done the most recent test ran for 20 seconds. So what it does, it basically, this is a website that has a lot of servers of its own. It clones your repository to their server. It sets the Python version 3.6 that we asked it to do. It will run the pip install command that we told it to run, so that the R package is installed. And then it will run PyTest. And it will say that, okay, everything is good. And something cool that happens is that this thing here, build passing, it reflects that what the state of the code is. If my, this is an image that they have here, right here, that you can just include in a markdown file. And this will change to failed if any of your tests failed. So if you're on your GitHub repository and you see that, oh, my build is showing failed, let me go to my Travis CI and see what test failed. Very, very useful. It makes your life very much easier because you don't have to worry about breaking things down or making sure everything is checked. Someone is doing that for you, and at every step along the way, you are making your code more robust from the very start. Doing it at the end of a project is very difficult, and so this is what Travis CI does: links to your account, does something you ask it to do in this configuration file. Most people use it for running tests, and as I have done, and it just runs the PyTest and tells me if everything worked with it. If PyTest had failed, then it would have told me build failed. I don't have time to make changes to the GitHub repository and show that. But yeah, that is the idea of having an automated test setup for you. Is there a question? I'm sorry, like this is supposed to be a workshop and this is kind of a lecture, but it was impossible to do this in 2.5 hours or half an hour that I had. But it's very useful, and hopefully you will go and look at it again. The last thing I want to cover, and that I'll cover very briefly in 2 minutes, is to build the docs for your package. This is a very, very cool thing again, and you do this by using a Python package called Sphinx. So let me go there. So what Sphinx does, it's notice that we have this weird folder called docs, right? So if you are in your Python package folder and you run something called Sphinx build, there will be a file a file pops up and it just asks you to enter some information. It's again a configuration file. So if I go inside this, you will actually see that file, conf.file. It asks you a bunch of things. What is the project name? What is the copyright? What is the author? Blah, 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 blah. What is the HTML theme you want for your documentation website? Stuff like that. It will ask all of that, and it will create the file. So if I look at my local repository, so if I do ls, I already have the docs folder. If I go to cd.docs, you will see that it has the conf.py with the same things. And when you run this make.bat file, which is basically a building file in batch file that runs a set of commands that are included in it. Like you can look at the bat file and it has a set of shell commands that it runs. It basically converts this uses this conf.py file and the auxiliary files that it has to create a set of HTML files that are basically your documents. And so that is under the build. So this is what it has built. So if I go to build, I have a set of HTML files that are the HTML. So if I, for example, and it has, so you define, like it has index, it has function. So if I, for example, if I go here, start index. This is documentation created. It uses your readme.md to create the first page. It puts the build.parsing, docs.parsing, and it also goes and looks for functions in your repository, and it uses the doc strings to create. This is basically what you see when you go to any Python documentation. It might have, I'm rushing through this and it might sound complicated, but it's actually very simple. If you just go and look at they have a one-page guide of how to build, use things build at any document you have, any folder you have, any Python package repository you have, and it's super easy to do. So, and again, the question comes up that, okay, I have all this stuff on my local repository, but I would like someone to, for example, if I go here, I go here, I would like someone to keep track of the changes. For example, what if you make a change in the function library, right? You have a new set of functions. So you would want someone to continuously generate the HTML files and keep it updated. You don't want to download it and then make HTML files and then push it up to your cloud so that you can have the website wherever that is. And so that is where Read the Docs comes in. Read the Docs is a website that will, just like Travis CI, it will go into your repository. It will look for the docs folder. It will use these conf.py and all the other files. These are pre-structured text. It is also not a language. It's not perfect right now. It basically makes things much easier than HTML. So if you just let me show that. You can change this. That's it. It's just saying that, oh, my website will have two depth of two. You will have a home page and then you go to another page that has function, right? So the very simple things that you can do here that would take a lot of code in HTML. Well, maybe not a lot, but definitely more than this. And so you would want some external service to keep checking, keep going to your docs folder, see if there have been any updates, and create the new website, right? For example, you have added new functions to your library. You want the documentation to be created immediately. So that is Read the Docs. So Read the Docs is a website. Oh, man. Sorry about this. Okay. So Read the Docs is also a website that links to your repository, and it has multiple versions of your website. So every time you have multiple versions of your documentation. So every time you make a changes, it will run the code again. And so it is a version control of your website. And if I want to look at my most recent doc, that is what you saw when I showed you in the local folder. And it again has this docs parsing thing, so that docs building has been successful. There is nothing that has failed. And that basically brings us to the end of creating a simple package. I covered a lot of stuff, a lot of stuff, but the important thing to know, I've put up a link for my final repository, and all the steps are there along the way. But this is the summary of the video. We factor the code to have functions, test for functions, and make sure that you have, if you can, have a downloadable data. You set up a small pipeline to remove all the functions to a separate module. You use JavaScript for functions and modules, very important if you want to be able to documentation. You put everything on Git that you already covered. The first part of this workshop. You choose an open source license. You include the code of conduct and a contributing guide. You set up a test. You already have test functions, but you set up automated test using ERES. CI, you're telling you to run test on the flow on the repository every time there's a change. Set up and write and publish documents using readme. So you use things to build a documentation locally, and then reader docs. Reader docs will continuously generate HTML pages as soon as you make a change. And so reader docs and CI are basically automations for things that you should not be worrying about, like making sure that everything is working. Someone has to run the test, make it automated. Someone has to make sure that the documentation is up to date, make it automated. Yeah. So we started late, so we still have 10, 12 minutes in our workshop left. I am going to do a very, very short exercise of, there's one more exercise left, of building your own website with GitHub. It's going to be very short, very, very short. It's as simple as the first repository you created on GitHub. But again, it's a very, very powerful thing, and I really want people to know about this, because this is what you can get if you have a very, if you spend time on GitHub. I'll show you just for motivation. These are the people who helped me, Natasha. If some of you might know Natasha Batala, VC Santa Cruz. And this is the website she created with GitHub, which is super cool in my opinion. And it links to all her projects, everything on GitHub. Everything is automatically set up. You can get there, but I just wanted to introduce you to the tool. So we'll take a 2 to 3 minute breather because I need some water, and also you need some mental rest. And we'll come back to it. I promise this will be like 10 to 15 minute exercise, and you will have a very basic website running. Great, thank you.
Where's the animals? I recognize them. Other than the oh wait, no, it's just oh wait, I found
Licensing fees.
I mean, yeah, I think because the point is that, as I would say, you have to like use two means if you website yeah, from what I've learned, yeah, from what I've learned from people. Oh, yeah. So you just create a license for MP5, and if you go to the website that I've linked, which have all the license documents. Okay.
Thanks for sticking around. The last activity that we're going to do is just build a very simple website. So GitHub provides a facility or a tool called GitHub Pages that basically just lets you host a website from a repository. So just like you created a repository, you can create a repository for your website, and it will have some HTML or some other format pages, and GitHub will directly convert them into a website and provide you a link to go to that website. So why GitHub Pages? It's simple, it's hosted online, and to just give you an idea of how simple it is to create a website. So you create a repository, and if you create a repository, if you want to create a personal website, it should be your username or github.io, because that will be your address to, like your website's address to. So you create that repository, you can clone your repository and make a change, or you can create a file there itself in the GitHub called index.html and just print hello world in it. And that's it. Then when you go to this username, you will have a website that says HTML hello world. And then things build on from there, where you add styles and customize. And we'll have a website with a custom style. And so it's just one more step as compared to this. So yeah, as I said, that it's free and hosted online. You can get it up and running very quickly. You have version control. You can have version control on your website because it is a Git repository again. And you will be able to share your code with others, and they can see how you build your website in the spirit of open source. And GitHub also provides you an option of you can create a personal website, and you can also create website for each of your projects. So if you don't like the documentation, standard documentation website that I just showed you, you can create a separate website of your project that has like some other interesting things that you want to put on it. So that's what I say, like a personal website, which has like where the link to the website is something like your username.github.io. If you have a project website, it goes like / name of your repository. But we are just focusing on the first thing now. So there are two parts of doing this. You create a repository and you use Markdown for heading. Also, Markdown is so easy, right? For heading and for lists, tables, it's very simple and intuitive to use. Instead of using something like HTML, I don't know how many people use HTML. Okay, let me just give you a very, very quick I think I have it over here. So yeah, a quick preview. This will give you an idea of what the HTML world looks like, or how you create an HTML. Yeah. So you want to create that. HTML is the text. Okay, hello world, this is my first CSS example, but you have to create all these tags, and then you have to include a style file and create a separate style file, that is the convention, which is a CSS file, where you define, okay, H1, which I use here, means have a color blue, have background yellow, border should be this thing. And if you want P, if I'm enclosing anything in P, then it has to be of a color red. So you do all these things and you get something like this. So basically my point is that there's a lot of code that is going on. So Markdown is just a simple way of formatting your text, and with Markdown, what you can do is you can use Git's inbuilt compatibility with something called Jekyll. So what Jekyll does is that it looks at your Markdown file and it converts it into HTML. You don't have to do anything. It will run the background process and will convert it to HTML. It has its own theme, so it will make the CSS file for you, and then you have a website with just some simple Markdown, right? And so that is what we are going to do right now. Go to your GitHub account and create a repository called your username.github.com. Go. Can you have? Oh, you have a website? And that's all. So it should be, for example, my username is Ishan Mishra, so it should be Ishan Mishra, whatever your username is, something like that.
Yeah.
Yes. Yeah, and this is something very basic. So you should currently just have a simple website, and you can initialize it with the README, just saying that, oh, this is a simple website that I built with Markdown. Doesn't really matter. README will play no part in building your website. Does everyone have a website with with your username or GitHub file? Do you have a repository? Anyone still need help? Okay. So next, what we do is we create an index.markdown file. So go to your GitHub repository and just create a new file. Create a new file and name it index.md. So you create a new file and you name it index.md, and in it type whatever you want. Okay, so I'm not creating this because I have already created index.md file, so I'll just show it to you. This is my index file, and this is the raw Markdown. So double hash mark indicate. So welcome to my website, whatever you want, something very simple so that we can move along. Oh. So does everyone have an index.md file in your repository? Your repository should currently have a README file and an index.md file. Forget about the context. Index.md is basically the index file of your website. So that is what your homepage will be like. So it's a rule to name it index. Anyone still working on that? Still creating the index.md file? Okay, then let's move on. Now you have this very simple file, and if you just go to settings, and scroll down a bunch. You'll see something called GitHub Pages. You see that? You go to settings, scroll down, you'll see something called GitHub Pages. Right? Now, here you will choose your theme. This is where Jekyll theme comes in. And so the first thing says source, like which branch do you want to build the website out of? We are on our master branch. This is our only branch, simple repository, so we'll let it be. Now you go select theme that you want. I like a theme called Dinky. Let's go along with that. It's the last one. You can change something else, but I have some specific things that the things that are specific to this coming up later. So everyone did this. You go select a theme. You go to the end, select Dinky, and just select theme. Anyone still working on it? No, good. So you have that. As soon as you do that, if you come back to your repository, you will see that there is a config.yml file. Do you see that? Okay. What is this config.yml? Just like travis.yml, remember, where it told Travis CI2, okay, this is what you have to do in this repository. You have to run these code and make up on these tests. Config.yml is just that. It tells Jekyll what it has to do. And so you should, I think, you will only have this thing. Theme Jekyll, theme Dinky, right? Does everyone have it? It's because we selected the theme Dinky. There are additional configuration variables that you can put here if you go and look up in the documentation of the Dinky theme. But you can just put it here. So this is the title of your website and this is these are two other configuration variables that you can immediately set up. So go ahead and type it if you want. Title and description for your website. Sorry. And save that.
Just to know, the title would be what appears in the
Yes.
title of the tab on the browser. Description would be something that Google would look like and just show under the name of the website.
And so now, yeah, you are done. You have made your very first website. You can go to your username.github.io, type it in your address bar, or the address is also provided if you go to settings and you go down, scroll down to GitHub Pages, it tells you that, oh, your site is published like this. I have a separate repository, so don't worry about that, but you'll have a link for the website. Everybody sees their website? Okay, good. And so this is a very, very first step that you just took to creating a website. I did the same thing, but I just moved a few steps ahead. And so my index.md looks a bit more involved. And so I've put a guide to Markdown, and I've also included a link to my CV. So if you just look at the raw code, very simple to do in Markdown. So this is basically another page in your website. My CV is here is linked to another Markdown file in my repository called about.md. And I have PDF CV in my repository, so I've just linked my CV to that. And if I go back and look at my repository, so it has a few more things than what you have. It has the CV file and it has about.md, right? And this is what my website looks like. So you all have that theme. I just have more text. Here I put some description about how much I love my mom's cooking, and I'm playing it up. And then I also put my CV here. So you can upload any document that you want. You can link a CV. You can upload it directly to your document, to your repository, and you have your very first website. So it's a few steps, very easily customizable. You can just stick to Markdown and a simple Jekyll theme. Before you leave, I'll just quickly show you. I created another website that uses HTML and CSS. So I have the index.html file, I have a CSS style file, and it can create something like this. It's a bit, it's a simple code. I have included that link in my in our workshop repository. But this is another style that you can go on, and because it's HTML and CSS, you can take amazing templates that you can find online because people have done a lot of work on this. And for example, there is a website called Templated. So the best part about building a website with HTML and CSS is that you don't need to be an expert in HTML and CSS. There is this website which has HTML and CSS files for templates like these, and they are all free. So everyone I talked to Natasha, I talked to another person called Rodrigo, whose website also looks super cool. And so they just use this template, and there is this another resource that I've linked to, which is an open source collection of graphics on Splash. Random photographs, you might find something useful. But the point is everything is open source. And so using these open source templates and open source graphics can create something like this, which is amazing. And HTML and CSS gives you the power to do that. And the point of GitHub Pages is that you have a free website, you have version control, and people can see your code and learn how to do code. Yeah, that is it. Thanks for sticking around. And yeah, sorry? Yeah, it's a static website. Yeah, you cannot include dynamic stuff in the repository. You'll have to link it to something external. Yeah. So what that means is that static websites are basically websites where you hard code what the pages should be like, or what the content of the pages should be like. On the other hand, for example, websites like Google or Amazon or something like that, they use databases. So they have this software that looks at the databases, find the appropriate things that you have searched for, and builds an HTML page on the fly. And so those are called dynamic pages. They're not important, but the point is that yeah, GitHub Pages super useful to create a website, free. A lot of website generators don't give you as much flexibility and also charge you a lot of money. Okay, thanks a lot for coming and sticking and learning all this. Again, the website has everything. We are recording the whole thing on Zoom. I will upload the video on YouTube. You can go back and look at the whole workshop course and figure out, reach out to us, use issues, go to our repository and create an issue for any doubt you have, and three of us will get back to it. And yeah.
Also, if you want to suggest other groups that you might know.
Yeah, you can just or you can fork our repository and edit a document and create a pull request. Very cool. Yeah, why not? Yeah.
And so just as a final notice, we will have a survey about the conference, and we'll put questions about the workshop also. So if you want to suggest things to be better, obviously,
Yeah, these are some other resources that I would recommend that you go look at. I don't have time to talk about it right now, so just there. Oh wow, I did not know that. Okay. Okay, yeah, so let's put that. That is super cool. Yeah. Okay, so yeah, the workshop is officially finished and free to go.